This is a quick video on arrays versus linked lists using an example to demonstrate the differences. So this isn't how to code them, this is just a comparison from a conceptual perspective. I'm going to give you an example based on storing a series of numbers. I'm going to make sure that these numbers will be stored in order, use both the array and the linked list. 6 numbers. Of course, many systems do actually deal with thousands and millions of items of data, and they could be student numbers, they could be customer numbers like telephone numbers, so they could be anything. Let's look at an array. If we wanted to store this data in an ordered array, we would first define the array that we wanted, so it would be an integer array, my array, and then we'd work out what size that needs to be and place the number in here so that we generate the correct size of array. We can then use the variable myArray with the index in order to put items in there, so it's 0 all the way up to n. So if this was an array to store 6 things, we would say myArray 6, and that will be index position 0 to n minus 1. So I'll just show you this. So we placed the data into an array in order. We would have 1 at index position 0, 3 at index position 1, no sorry, that's not 3, I mean 2. We would have 3 at index position 2, and then 5 at index position 3, 7 at index position 4, and 8 at index position 5. So it's 0 to n minus 1 is the variable that you would use in order to process the array. So 0 will give you 1, 1 will you can set that to 2, 2 you set that to 3, ... Now imagine if you wanted to add a number, so you want to insert 4 into the ordered array. This is where it's quite a good comparison with the linked list, which I'll show you in a moment. If you wanted to insert 4, you would have to find the number that's greater than the number that you're inserting, and when you found that, you would need to take a copy of it so you don't lose it, and then you would set, say, my array, the current position, the one that you're currently looking at, the one that is greater, set that equal to the number that you're wishing to insert. This is a C type syntax, but it shouldn't really matter. You can do this in most languages. And then you have a copy, say e.g. in temp, and that would store your 5. So that would become 4. Let's cross it out instead using the red. So that's no longer there, and instead we have a 4 in there. 5's now in temp, and these are the same. So you'd have to shuffle those along as well. So you'd have to go to the next item, take out what was in there, put in the 5, and then go to the next item, take out what's in there, and put in what's in temp. So there's quite a lot of faffing around to insert data. And the same is true for removing data. You either remove it and leave this empty. So if you wanted to say remove 7, you could just remove 7 and leave it empty, or you could shuffle this along. So it's not so straightforward, but what is easy is if you want to access an element. I want to access element current plus 1, for example. I can go directly, so that's random access. In comparison to an array, I'm going to now show you storing these numbers in order in a linked list. You can find linked lists in C# or Java collections, so they'll be ready-made, or in C++, standard template library, Python, PHP, they have list implementations. So we want to store 821753 in order using a linked list. What we need to do is create a variable that allows you to store 2 items. It needs to store the value of the data, which in this case is an integer, so this is an integer, and a pointer to the next integer. So when you start off and you create your first element, it will just have your first value, and then you will set it to set the pointer to null, which means that is the end of the list. So imagine your list was called my list. My list would be pointing to the start of the list. Then when you add your next item, you create your item, give it the value, and this will have a memory address. For example, it will be longer. And then you want this item here, so item with the value 1, to no longer be a single list item, but to point to another value. This pointer value needs to contain this value here. So you can obtain the address 11101010. It would be longer, and by having that there, you can now access what's in memory address identified by 11101010, which will give you 2, and this now becomes the end of the list. So the second item that I've just entered with the value 2 is now the end of the list. So we have a list of 1 and 2, so that's this one and this one. We now need to place 3, so we can create a node. They're called a node, so that's the conceptual term used. We place 3, and imagine this has a memory address of, doesn't matter really, it's just an example. What we need to do is find out where to place it. So we want to place it at the end of the list. We take away the null value, we place the null value into the new item, and we take the address of this one and we place it in of the new item we've just entered, and we place it here, which creates the link to the next item. This is the start of the list, and this is the end of the list. So let's add another item. So we need to add 5. So 5 could be here, some random place, and I will put that in an easy location for me to indicate. Now I want to find out where to place that. I'm going to place it at the end, so go to the end of the list. In this case that's quite straightforward. Place the address of the new item, which causes a link, and then put a null terminator on the new item. So that's adding to the end of the list. I'll leave it there. So if I want to now insert 4, inserting 4 is relatively straightforward. I want to place it here. So imagine I've created my item somewhere in memory, 10101010. Hopefully that'll do. I want this to be pointing to the 5. That's what I want, and I want this one to be pointing to the 4. Now how do I do that? This could be the current, and this is the next. So I know I have that information available to me. So what I need to do is make this point to next, which is 111000, and the current item to no longer point to next, that one, and to instead point to the new item, and instead point to the new item, which is 10101010. So when I make this node here, I get the memory address of it, store it, and then make this equal to it, and that has now added my new item. Remove 4. So if I want to remove 4, I need to, again, the current item here, I need to be here, and I need to check if the next one is 4. So the current one is 3. Is the next item 4? If it is, then I need to stop pointing to it. But what I need to do first of all is get the next point, the next node's next pointer. Okay, so get next node, next pointer first, then remove the next node, and then make the current node next pointer equal to what I've saved. Okay, and then that will work. So again, let me delete this now, and let's just remove this so that it wasn't complicated to understand. So we placed what that was the one we wanted to remove, so this was the next node and we wanted to remove it, so get that value and put it into here, and that's now pointing back at this. We've now deleted that, and we can use free to get rid of the memory for this value. And hopefully that makes sense. So you should be able to see that when it comes to arrays and linked lists, you should now know that arrays can be accessed randomly to obtain specific data. Linked lists can be slower to search. You have to start from the beginning of the list and go through the list. But arrays can be slower in terms of inserting and deleting data, especially in ordered arrays, whereas lists can be quicker to insert and delete data by manipulating the pointers. With lists you can end up with items of data stuck in memory, so you need to be careful and ensure that the language has facilities for either garbage collection or for you to free up the memory when you've removed items. In terms of arrays, you can either shuffle all the data along or you can leave holes in your array, which could be a waste of space depending on your application. Careful consideration of data structures needs to be made in order for you to make a good choice for your application. So hopefully that brief overview of arrays versus linked lists should help you get started. As a reminder, it was a conceptual overview rather than a coding comparison.